Welcome to Quest Edu Physics students. In this class, we are going to do some problems on concave and as well as the convex mirror students. Before doing the problems, we have to know what are the terms used in solving the problems. Okay, students. Then also, we apply the same thing while doing the problem. And one more thing, we will learn about the sign convention in mirrors also, students. Basically, we have to understand what is a mirror is. Everyone knows mirror is a transparent substance which is silvered at one side. Okay, students. Transparent substance which is silvered at one side is known as the mirror. Mirrors are classified into two types, One is the plane mirror and second is the spherical mirror. Spherical mirrors are further divided into two types, students. One is the concave and second is the convex. First, we have to understand what differs from a spherical mirror to plane mirror. You can understand the things very easily. So, students, I said, is a transparent substance which is silvered at one side. Let's say it is a transparent substance. We are silvering at one side and we call it as the plane mirror, students. It is the silvered surface and it is the reflecting. It is a plane mirror, student. Just imagine that we kept an object here. Here we are keeping an object here. Then, where we see this object inside the mirror? The answer is simple. One ray appears to be passing like this, and one ray. Okay, students. These are the rays. I'm dropping a normal here. And also, one more normal is dropped and one more normal here. If you recall the laws of reflection, students, this ray will reflect back. The same could happen to this ray. If you extended these rays backwards, they appears to be meeting at a particular point, students. And this position, we call it as the image. And it is the object. If we watch it clearly, it's the same thing what we are observing daily. Well, students, if you stand in front of the mirror, you will find yourself inside the mirror. It is the object and it is the image. Here it is the real object and it is the real object, students, and it is the virtual image. The same thing we are applying in case of spherical mirror now, students. See this? If it is the mirror, it is the mirror, students, spherical mirror. The two concave mirror, students. Okay, it is the principal axis, as you know that. One ray to be taken like this, students, and one more ray. Okay, students, then after they get reflected, students. Okay, we have to drop a normal here. This ray travels like this. And again, you have to drop a normal from this point. This ray passes in this way. Now see, extend this one, the rays which are coming from the object. Okay, students, see this. When it is the plane mirror, it appears that it has been appear to be meeting here. See, here in this one, the range being increased here also. The same thing is happening. That is the difference between a plane mirror and as well as the concave mirror, students. If you keep any head here, it appears to be bigger. Okay, students. Here it is of same size, but here it appears to be bigger. In this way, a concave mirror makes the thing appears to be bigger. Okay, students. Makes the things appears to be bigger. If you go with a mirror, we have to recall few terms which are very important in mirrors. One is the principal focus, students. The second one is the radius of curvature. The third one, the object distance. And fourth is the image distance. Fifth one is the focal length, students. Here, students, let's take a mirror. It is the concave mirror. If you watch it carefully, the lines what I am drawing, it indicates the silvered surface, and this one is the reflecting surface, students. As usual, you have to locate the pole. Pole is the central part of the mirror, students, and it is the principal axis. Okay, students, it's the pole and it's the principal axis. You have learned that what is the focal length is. Before that, we have to understand the methods of tracing of the images. You should remember that at least we have to take 2 light rays to draw the image, students, at least. And one more thing we have to remember, the rays which are coming from infinity appears to be parallel to the principal axis, students. One such ray is coming from infinity. Take the students. Okay, these rays are coming from infinity. I took a set of rays. Here, to find out the image or to find the focal length here or the focus here, we must strictly follow the laws of reflection, students. In laws of reflection, you learn that the angle of incidence is always equal to angle of reflection. Here we are doing the same, students. We have to drop a normal. It's the normal which drawn. Okay, students, from here, I'm dropping one more normal. Okay, these are the 2 normal, students. It is the incident ray, students, and it met this mirror and reflects here. And the same thing could happen to this. The 2 will meet at a particular point. It is angle of incidence. It is angle of reflection. Okay, students, this point is the focus. What is the focus here? Focus is the point on the principal axis where the rays will meet after reflection, students. Focus is the point on the principal axis where the rays will meet after reflection. It is the focus, or we call it as a principal focus or focus point. And it is the pole which is the center of the mirror. And third one, we have to remember the center of curvature and also the radius of curvature. First, we have to remember what is the radius of curvature is. Radius of curvature is the radius of the sphere in which the mirror is once apart. Okay, students. It is the radius of the sphere in which the mirror is once apart. And this point is known as the center of curvature. Here, the unique property of the center of curvature is, students. Okay. Here, when a ray proceeding along the center of curvature, it doesn't get deviate, students. It come back to initial position here. What way it followed? It will come back to the same place. is the nature of the center of curvature, students. Actually, center of curvature is nothing but a normal which is drawn to the tangent of the curved surface. If you say it is the curved surface and we draw a tangent here and we dropped a normal. Here I showed. That normal is which is drawn from the tangent of the curved surface is the center of curvature, students. Okay, students, the focus. And this distance from the pole to focus is known as the focal length, students. Here it is a concave mirror. It has the focal length which is negative, students. It is taken as the negative because of the sign convention, students. Already you learned about the sign convention. According to the sign convention, okay, the rays here are falling from left to right. The distance which is measured opposite to the incident ray always to be taken as negative, students. The distance which is behind this reflecting surface has to be taken as positive, students. Sign convention tells us that only. That's why it became negative, students. I told you, students, while doing the problems, we have to aware of few physical quantities. Already we discussed about those. What is the center of curvature? What is the radius of curvature? What is the principal focus and what is the Okay, students, it is the principal axis. What is the principal axis here? Principal axis is nothing but the normal which is drawn from the center of the mirror. Okay, normal which is drawn perpendicular to the mirror, students. It is the principal axis. Yes, see, students, already you learned that it is the focus and we have the center of curvature. Now we are going to talk about what is the object distance and image distance, students. See, I'm taking an extended object, students. It is the extended object which has measurable dimensions, students. And it is the pole and it is the object. The distance between pole to the object is known as the object distance, students. It is the object distance. Okay, we have to find out the image distance here, students. We have to take a ray which went like that. After reflection, it passes through the focus here. And one ray we have to take which travels in this way. And here also it is following the laws of reflection, it reflects. Okay, students. After reflection, these 2 points, these 2 rays intersect with each other. They will get the image, students. This is the image, IG. And this distance is known as the image distance, students. And this one is the focal length. Okay, in concave mirror or convex mirror, the 3 are related like this, students. 1 upon F is equal to 1 by V plus 1 by U, students. Okay, students, the reciprocal of the focal length is sum of the reciprocals of image distance and object distance. Here we are applying the sign convention, and you will get u as negative. Sorry, it is v as negative, and u, it is also negative, and focal length also negative. And substituting all, you will get 1 by f is equal to minus 1 by v minus 1 by u. Again, we get it as 1 by f is equal to minus of 1 by v plus 1 by u. Minus minus get cancelled, and 1 by f is equal to 1 by v plus 1 by u. Okay, students. Then the next important term here is the magnification, students. What is the magnification? Magnification is nothing but the ratio of image distance to object distance, students. The ratio of image distance to object distance is known as the magnification. Here, magnification can be found it as m is equal to minus v by u. Here in this case, the image is inward. Okay, similarly, if you consider the heights, it is the height of the object and it is the height of the image. Magnification can also be written as height of the image to height of the object. Or broadly, the magnification is minus v by u, that is equal to hi by h naught. These formulas are very important, students. One is the mirror formula. The second is magnification, students. Magnification, okay, can add as m is equal to minus v by u. And also magnification is the ratio of the image distance to object distance. Students, let's say the problem on the board, students. The problem is an object of height 10 centimeter is placed 20 centimeter from a concave mirror of focal length 12 centimeter. Where does the image form? What is the magnification is saying? Okay, students. How to do the problem? First, we have to take the physical quantities what are given to us. He said an object of height of the object he gave, and place it 20 centimeter from a concave mirror. Means what? He kept an object in front of the concave mirror. That means what? Given object distance u is equal to 20 centimeters squares. Okay. And height of the object. Height of object is given HO. (10 centimeter). Focal length also given, students. Focal length f is equal to 12 centimeters, students. If we depict the diagram, it could looks like this, students. Is the thin concave mirror. Okay, students. It is the principal axis. Say it is the focus, and it is the center of curvature. And he gave focal length is 12 centimeter. It is. And object distance is 20 centimeter. Means what? It is somewhat in front of the center of curvature. Okay, here the object is. Let's say it is the object and kept at a distance of u. And you know that how to draw the image. Roughly we are drawing. One is passing through the focus. One has to pass like this. The two will meet at a particular point. And we'll get the image here. Okay, students, it's the height of the object and it is the height of the image. It is the inverted image. Okay, students. Then we have to apply the sign convention now. Focal length is taken as negative. Okay, according to the sign convention, f becomes negative, that is minus 12 centimeter. An object is kept in front of the mirror. It is u also minus 20 centimeter. And third is the image. We depict the diagram, but actually we don't know where the image would form. Okay, students. Do remember that when you are finding the unknown quantity, you should not apply the sign convention to that. Most of the time we get confused over, and for all physical quantities we apply the sign convention. You must remember that for unknown quantities we should not apply the sign convention. Okay, students, that's why we has to be formed. From mirror formula, we know that 1 by f is equal to 1 by v plus 1 by u. Okay, students, then it can also be written as, I am substituting the value of the f, 1 by 12 negative is equal to 1 by v. We didn't apply any sign convention for image distance, plus minus of 1 by 20. Okay, students, and we had it as minus 1 by 12 is equal to 1 by v minus 1 by 20, or it can be written as 1 by 20, I am taking this here, minus 1 by 12 is equal to 1 by v. Okay, students, it can also be written as 1 upon v is equal to, okay, 12 minus 20 by 20 into 12. Okay, students, here we got minus 8 by 20 into 12. 4 2s, 4 3s, 4 2s, 2 1s, 2 10s. Okay, students, we had v is equal to minus 30 centimeter. V is minus 30 centimeter. Here negative sign indicating that it is the inverted image, students. Okay, it is the inverted. Negative sign here indicating that it is the inverted series. It is real image which can be taken on the screen, and it is inverted. First part of the problem is over. Where does the image form? The image form at a distance of minus 30 centimeter. The next term, the magnification. Magnification is what? Minus v by u. Okay, students, here minus of minus 30 by u also minus 20. Magnification is equal to 1.5. Here this negative sign indicating that, okay, it is inverted image, students. Let's do one more problem, students. This time we are doing the problem on convex mirror, students. And before we did on concave, now it is convex. As you know that the major difference between the concave and convex is the positive mirror, means what? Its focal length is positive, where the concave is negative. Let's see this problem. A 5 centimeter long needle is placed 10 centimeter from a convex mirror of focal length 40 centimeter. Here he gave us, we are doing the solution, height of object, I mean it is the needle, height of the object HO is equal to 10 centimeter. Okay, students. And the mirror is convex. Focal length F is equal to 40 centimeter, and is asking us find the image position. I mean it is V. V is equal to how much he is asking, and object distance he gave. Object distance is okay, students, U is equal to how much? 10 centimeter. These are the quantities given to us, and he is asking nature and size of the needle. Means he is asking the magnification and height of the image he is asking. Let's use the formula, mirror formula from mirror formula. One by F is equal to 1 by V plus 1 by U. Here we are using the sign convention, students. Focal length of the convex is positive. That is, it is plus 40 centimeter. Height in front of it is obviously plus 10 centimeter. Object distance U is equal to minus 10 centimeter, students. And as you know that, okay, for unknown quantity, we should not keep the sign convention. Then 1 by 40 is equal to 1 by V. We are not putting any sign convention. Plus 1 by 10. Okay, students. It is 1 by 10, 40. Here minus, we brought it here. 1 by 10 is equal to 1 by V. Then 10 plus 40 upon 40 into 10 is equal to 1 by V. Okay, students, it's 50 by 400 is equal to 1 by V. 58. We got the image distance. V is equal to 8 centimeters, students. Here it has a positive sign. Means what? That it is the virtual image, students. The image is virtual. Let's find the magnification. You know that magnification M is equal to minus V by U or HI by HO. Okay, students. Magnification can be had as M is equal to minus of V, already we got 8, by U is equal to minus 10. Okay, students, it is 8 by 10 means it is 0.8. The magnification is less than 1, students. That means it is smaller than the object. And finally, we have to find out the height of the image. That is 0.8, substituting here, is equal to height of the image by height of the object. It gives us 0.8 is equal to HI by HO, height of the object, 10. Okay, students, and we got HI is equal to 8 centimeter. Okay, students, if we depict the diagram could be like this. It is a convex lens, convex mirror. Principal axis, and it is a pole. Okay, students, it has a focal length of how much? 40 centimeter. Just say it is F is equal to 40 centimeter. An object is kept at a distance of 10 centimeter here, somewhere near. Then we have to draw the diagram, students. One ray has to be taken from the head of the object. It's taken like this. It gets reflected in this way. Then the second ray is taken from the head of the object, passes in this way, and it gets reflected. If you produce it back, it goes on, and this ray passes through the focus. Here the image is formed. And the characteristic of the image is, it is virtual image, but smaller in size, means diminution. I hope you understood how to solve the problems. When the concave or the convex lens is given. If you like my video, please subscribe my channel and don't forget to forward the video to your friends, students.